Hello everyone, welcome back to your channel The Ghadiya Insan. So from today's video, we'll be starting the evolution of neural network. So we'll be studying like how it moved from ANN to RNN, how it moved from RNN to LSTM, LSTM to transformer, transformer to LLM, LLM to agents. We'll be taking a simple example, and through that we will be trying to understand what this ANN could solve, what it couldn't solve, what this RNN could solve, what it couldn't solve, what this LSTM could solve and what it couldn't solve, and similarly for all these, like why RNN was brought, why LSTM was brought, why transformer was brought, what previous stage couldn't do that it could do. That we will be understanding. Okay, so suppose example problem is translation. Okay, example problem is translation. That is, suppose you want to convert English to Hindi. Let's say the sentence is I go to market. Okay, so generated output should be मैं बाजार जा रहा हूँ. Right? Getting. So this is the example problem. That is translation. We'll be trying to understand through all these stages one by one what each could contribute and what it couldn't do that next state was brought. Okay, so let's start with ANN. Right. So ANN, as you already know, full form is artificial neural network. Right. Network. It consists of input layer, hidden layers, and output layer. Right. All this we have already discussed. Right. It consists of neurons connected through some way. Right. Okay. So what problem first this ANN could solve? What problem this ANN could solve first? Right. Let's first understand that. So so the traditional programming couldn't recognize complex patterns like recognizing handwriting of someone, handwriting, or recognizing images. Okay, so this what traditional programming couldn't do. So NNN solved this problem. NN solved this problem. How? By directly understanding the complex patterns and non-linear relationships. Okay, and thereby able to perform tasks like recognition and classification of images. Right? Got it? This is what we are already aware. Right? This is what we are already aware. But you know what is the problem with ANN? ANN treats and treats every input as a independent kind of entity. It's not able to understand the order and sequence. Task that I have mentioned above is a translation, right? I go to market. Sequence of every word very becomes very important in converting it to Hindi, right? If you see, I am not written directly like I Hindi word mein. Market is coming first at end, but here see bazaar coming first, right? So sequence becomes very important. Okay, okay. When we know the sequence, our brain like kind of how, like suppose if I do translation, how I will do, try to understand. Like I go to market, I go through the complete word, then kind of understand it, right? Remember it. Each word I remembered. I then came go, then to, then market. Okay, then we translate, right? So what is the problem with ANN? Okay, it treats every input as an independent entity. Okay, it's not able to understand the order and sequence. No memory, right? Or context of previous word, right? This was the issue. So it couldn't help in tasks where the order or the sequence becomes important. In translation, the word order becomes very important. Okay, man bites dog and dog bites man, right? You can see really, right? The order is changing completely this meaning, but this ANN will treat both sentences simply as a bag of words, not able to understand the sequence, thereby no translation will happen certainly, right? Getting what was the issue with ANN? What it could solve? Yeah, it could recognize complex pattern, thereby solving tasks like recognition and classification of images. But to problems where sequence becomes important, where order becomes important, like when we are translating a language from English to Hindi, let's say, so what order becomes very important, right? Like man bites dog and dog bites man are literally different, right? But what ANL will do? It will treat both sentences just as a bag of words. As a result, it's not able to translate because for translating, we need to know the complete context. We need to know the order. We need to know the sequence, right? Because via order and sequence only, we can kind of translate, right? You can see here clearly, right? Man bites dog and dog bites man are different. Why? Because the sequence has been changed. Okay. Accordingly, we can translate, right? So to solve this problem, RNN came. So first ANN came. To solve this problem, RNN came. RNN that stands for Recurrent Neural Network. So it tried to solve the problem of ANN by kind of adding a memory. Okay. So what it did is sending previous state output as a input to the next state. Getting so memory because of the previous stage output, it was aware like what is previous. Okay, suppose let me I'm telling with you this example only. First, suppose RNN saw a word I. Okay, okay, let's say it generated the output some token ID like 12 or something. Okay, it is 2. Next is it M. Okay, so output of the previous one is already known to the RNN. Okay, so it remembers, yeah, it was I M. Then again it came going. Okay, going. Okay, so it has the context of I, then M, then going. And at the end of the sentence, it has a kind of summary or context of the word. Okay, so when I am going to market ends, has the complete context summary that yeah, I am going to market. So it can accordingly translate. Okay, getting so RNN, we write it like what problem RNN solved. Problem RNN solved. So this problem it was able to solve, right? This problem it was able to solve. Okay. At the end of the sentence, it made a kind of a summary or context of the word, and accordingly it can translate. Why? Because of memory. He was knowing, like before am, I is there. Before going, am and I is there, right? I am going. This ordering it was able to maintain as a summary. Okay, and thereby because it has the complete context in the memory, what is the complete sentence, what is the complete order, so it was able to translate, right? Problem happened where, do you know? Problem with RNA. Yes, for small sentences, okay, it's able to remember. But when the sentences started becoming longer, it kind of started forgetting the older words. Okay, so that's the issue. For small sentences, can do, but when the sentences is very big, like I am going to market to buy fruits and vegetables, so there is a very high chance by the time it reaches fruit and vegetable, it may forget that I and am. That is what I'm saying. Example: I am going to market to buy fruit and vegetables. So by the time by the time it reaches to vegetable, there is a chance it may forget I and am. Okay, thereby, as it has forgotten, thereby the translation won't be accurate. Getting? So yes, this RNN solved the problem of ANN. Yeah, it kind of make the data sequential. Okay, it was able to make the handle this sequential data by adding a memory, right? What it did is sending previous state output as input to the next state, right? When it reached to, suppose when it reached to, where's the example? Yeah, going. Okay, so by the time it has come to going stage, it is already aware of I and M. Okay, so this is right. Okay, so this is how it was working. But when the syntax became very big, like I am going to market to buy fruit and vegetables, so by the time it reaches vegetables, there is a very high chance we forget I and M, and thereby not generating accurate result, accurate translation for bigger sentences. Getting? So this was solved again in the next stage by LSTM. Okay, that stands for long short term memory. Long short term memory. So what it did, what problem it solved. Ah, this is what we are doing, right? What problem it solved and how. So what it started doing, okay, it started kind of remembering relevant information. Okay, not remembering everything, not remembering everything. And how this was achieved? By upcoming gates of gates. So there were three gates: input gate, forget gate, and output gate, which which together which together decided whether the information should be passed to the next stage, should the information be forgotten, what information should be given in the output. Actually, I have written the work of each gate, right? Suppose this is the work of input gate, right? Input gate, break it down. This is for the input gate, right? Put the information we forgotten. This is for the forget gate, right? And for the output gate, getting. So doing this, it was able to remember the relevant information, due to which it could remember large context, and thereby able to translate accurate even for larger sentences, right? Okay, but here also the problem happened. Here also the problem happened. If you observe from NN to RNN, okay, everything from this covers everything from ANN to RNN to LSTM. Every input or word is processed one by one. So when the sentence becomes very large, or the word that is too much words in the sentence, then training the training becomes complex. Okay, what happens? Training becomes complex, and bigger documents couldn't be, or paragraphs couldn't be translated even by STM. Okay, so all these where what happening? Every input or word is processed one by one. Let me write it down in everywhere, every word. Okay, so it's a clarity. So here also, right? Here also, every got deleted from it. Is every no not deleted. Every input or word processed one by one. Every input or word processed by. Same with RNN, right? Same with RNN. RNN and okay, got it. So this processing of word one by one was later solved in transformer, where parallelly processing of word started. Okay, parallelly processing of. So, but before coming to this, I want to talk about one more topic, that is NLP. Okay, NLP. So NLP stands for Natural Language Processing. So as we all are aware, computer can understand only numbers, right? So how it can perform tasks like understanding a text, or thereby translating, doing, getting, how it can do. So NLP provides techniques like word embedding, word to vec, all these techniques you can search ChatGPT, you can do all these things. Okay, which is used to convert text to vector and thereby making providing structure and meaning. Let me explain. Suppose you convert a word to a vector. Okay, so what? Suppose market and bazaar are two words, right? So they are converted by NLP techniques to a number. Okay, so as this bazaar and market are closed, so they will have vectors such that the coordinate distance between them will be very less or minimum. Getting NLP is not a model set. It is not a model. It is not a model. Not a model. The branch. The branch. What is a model? Something solved for. Okay, it's not a model. Okay, got it. It's a branch where we get to know all the techniques to convert word into something number that can be structured and meaningful. Okay, and when we provide techniques like this, we use to convert text to vector and they are providing structure and meaning. Like market and bazaar are two words. They are converted to vector by NLP techniques, and since they are closely related, so the vector distance between the two words will be yes, fitting. And this same NLP used techniques are used in RNN LSTM to predict the next word or the translation. Getting translation is also kind of predicting, right? What will be the next word, right? So here I was saying it is able to translate. So internally it is doing NLP only. Okay, getting. You must be wondering like how it could convert this text translation. Why? Why of which internally it used NLP techniques through which it converted text to number, and NLP kind of provided a vectors through which the words that were related were very close, and through that it kind of finds the probability, it finds the distance which is the next nearest word, and thereby it predicts the output, right? Which is the next nearest word, thereby out. So in today's video, till now we were able to see like, yeah, this was the problem, example problem, translation like we wanted to convert English to Hindi. This was the sentence. I go to market, मैं बाजार जा रहा हूँ. So what KNN could do? We could see that yeah, no sequential data, no ordering. Thereby, it was not able to do translation because for translation sequence becomes very important. मैं dog bites man and man bites dog, both become very different because of the just of the sequence. Try to feel. Okay, I'm trying to making you feel, you also just feel. NLP, we understood like NLP, what is that? Computer couldn't understand the language by itself. Means it understands only number, not text. So NLP provides some technique through which text could be converted to number, thereby providing a structure and meaning. Words that were related were having their vector distances less, okay, closer. Then we came to RNN LSTM. RNN kind of added a memory, okay, which was not present in ANN, and thereby it was able to predict the kind of keep a context memory and thereby do a translation, right? If you find that somewhere I have been speed up, then please let me know, mark it down as comment, and you can rewatch the video if you have not been able to understand, right? I have tried to take example and explain everything. These all are very big topics. We go in deep. Only this lecture can be made for 6 hours, 10 hours, 10 hours, right? For individual topic. But that's not now very important, right? We should be aware of everything, but our end goal is we should be able to do hands-on, which is most required in the market. That is preparing the model, preparing the agent. Getting so the next video we have been able to do, we will be covering transformer, then we'll be covering LLM, then we'll be covering agent. Okay. And after this, our all the theoretical part will be over, and I will be setting up the AWS account, showing you how to set up the AWS account and all, and about giving you again exposure to the Amazon Bedrock services, and we'll be good to go to prepare the chatbot. We'll be starting the chatbot. Okay. So that's all for today. Thank you. Keep exploring, keep coding, keep feeling. Cadence. Wow.